Hey, in this video, let's do some more shader programming, continuing on with our fragment shader, but this time I'm going to demonstrate some of the math functions, some more of the built-in functions that are in this shading language. Last time I had put together this shader that just makes a checkerboard pattern that scrolls. And I'd like to do the same thing, but without using this texture. This is going to be a little tricky and a little bit mathy. It is really cool to be able to use textures and do different effects with them. In fact, with certain shader effects, you need to use textures. It's the only way. But it also helps to explore what kind of functionality is built into the language, so that we can have an understanding of our tools, what kind of operations we can do to make our textures look really cool and achieve different effects. So I'm pretty much going to get rid of all of this and try some other stuff. Okay, so if I wanted to just sample my texture, let me start over here. I want to get from the main texture and my input UVs. Okay, back to normal. Here's my smiley face. Alright, I would like to at first try exploring a couple of the tools we have with the vectors we're using. Right now there's this fixed 4 or float 4 RGBA vector. We have a two-dimensional vector in this UV coordinates, and they have some kind of cool properties, things that they can do in this language. So with these vectors, we could pick off an individual color component with dot, say R for the red channel, and we can use these color channels in our math. So what I'd like to do is try making this like an average color. Let's say average. Let me get our float 4. This is going to be the text color. Alright. So I'll fix all this stuff in a moment. So I'm going to get the texture color first, and then I'll take the red, the green, and the blue, add them together, and divide by 3. So that should give me an average color. And then I can use that average color to construct this, this color that I'm going to eventually return. So I can specify, if I just put in average, this is going to fill it in, each of those 4 components of the float 4, and it's just kind of a shortcut, but I'm going to write it all out because I actually want I want this last component to stay as a 1 so that it's fully opaque, no transparency. So let me go look at that. Alright, so it's turned it completely grayscale, and this is a good way for doing that. It's taking all the color components of a single pixel and combining them, calculating an average, and using that average for all of the new color components. So when red, green, and blue are all equal to each other, you get gray. And this is one way to do that. Another way is we could pick out a single color channel and avoid doing this average calculation, as long as we decide that it's good enough. This will let us visualize one of those color channels. So let's say textcolor.r, and I could do textcolor.r, textcolor.r. And this gives me another kind of grayscale, but this is just the red component. So it's ignoring all of the green and blue information from this smiley face image and it's just using the red channel value for every other color channel. There's a shortcut here too. So I've just been accessing a single color channel, but this language supports what's called vector swizzling. It's kind of a cool name, where I could do textcolor.rrr, and that gives me a float 3 of these 3 values, red, red, and red. I could do that. Check out the result. Should be the same thing. I can do the green channel. It's a little bit different. Blue channel. That one's a lot different. So you can see that there's a lot of blue information missing. Where there's yellow in this image, there's no blue. And I can go back to normal with the full RGB. There we go. So you can do some neat things with vector swizzling. You can even swap these around. BGR if I want to. Get some different inverted coloring, or just mess around all over the place with this thing. So that's kind of cool. Can have its uses. So what I'd like to do here, I want to recreate that checkerboard pattern, but using strictly math and no texture information. So let me get rid of this text color. I want to figure out what this is going to be. So to try to figure this out, I want to explore sort of the coordinates I'm dealing with. If I use, let's make a float 4 that uses my UV coordinates. Let's say the X. So let me use the X coordinate 3 times to fill up this with grayscale. So now I've got some values going from 0 all the way to 1. 0 being black, all of those color components become 0. White, all the color components are 1. And then in the middle, I'm getting this gradient. This is just smoothly increasing to 1 on the right side. So that's a visualization of my X coordinate UVs. Let me look at my Y coordinate. Alright, so I've got 0 at the bottom and white at the top. So what I'd like to do is think, well, I want to make this a checkerboard pattern. So in some places I want completely black, some places I want completely white. And we saw one way to split things up to add a sharp line was to use the step function. So let me take the step of these coordinates. Let's do the X again, and just 0.5. So if this coordinate happens to be less than 0.5, this step will return 0, and if it's greater than 0.5, it'll return 1. So I'll either get 1 or 0 in these color channels. Alright, let me switch these. Get the black on the other side. Okay, not that it matters all that much. Alright, so I have created this stark contrast, black on one side, white on the other side. And I kind of want to do this for both dimensions to try to get a checkerboard pattern. So what I could do is sort of add these step functions. So now I'm going to end up with values that are 0 plus 0, 0 plus 1, 1 plus 0, or 1 plus 1. So there's a possibility here. You'll see these are my zeros. This is 0 plus 0. Up here would be 1 plus 0. Up here, over here would be 0 plus 1. And then in this corner, I'm going to get 1 plus 1. So all of my color values here are 2. And that's out of the range that I want to consider. So I'm going to use another function that's going to sort of wrap around those values. And if you remember from previous lessons, we've talked about the modulus operator, modulo, that lets you do some sort of simple repetition. So that gives me a hint as to where I can go with this. So let me comment this out and look at that function. So in this language there is an fmod function that does a floating point modulo, which is a little different in that you can use floating point values and not just integers, but it still gives you the remainder, what's left after dividing. So dividing evenly. So let's say we use like our x coordinate and let's say 0.5. Let's cannot convert from float 3 to half 4. Float 3, oh, because I need another coordinate. Okay. Missing my alpha value here to make this a float 4. There we go. Okay, so what this has done is gone from 0 to 0.5, so we get to middle gray, and then it resets it back to black and goes up again to middle gray. Okay, we can take advantage of that. So this lets us repeat every 0.5. So if I repeat this, let's see, I would like to repeat this stuff every time that it goes past 2. Let's see, that's float 4. So fmod this whole thing 2. Okay, so now instead of getting just that one black box with 3 white boxes, I've got 2 black boxes. And let me see if the tiling works. Okay, so if I change the tiling, scale up my UVs, it stretches. Anything over 2 just keeps going. Alright, so we're not there yet. Okay, so it looks like I'm going to have to do more repetition here. So let me try to break apart these variables to make this easier to work with. Let's say we have a float 2, make those our UVs. And then I can just use UV here. And then let me repeat my UV coordinates. Every time they go over 1, we're going to repeat them. And that should make it tile better. Cool. Alright, we got our checkerboard going on. Let's finish up the rest of it by just making it, let's make it blue. Alright, float 4. Okay, and now I've got blue and black, but I want the black to kind of swap. So let's do 1 minus all of that. And then we do 1 minus this thing. Okay, cool. So now I've got white and blue instead of black and blue. And now I want to animate it. So I'll need some time that's moving. All right, and then I can modify my UV coordinates using that time. Let me do them separately. 0.2 and time times 0.3 will make them move at a different rate. Give a little more interest. Right, I think that's pretty good. I can scale my UVs, so times 2 times 4, whatever. And it looks like the same thing. So achieved completely without textures, just using the functions that are built into this language. Some of this math can be pretty challenging, figuring out, kind of exploring this this function space and the parameters, how they're changing from left to right across your geometry. Can be a little bit intimidating, but if you explore this and just play around with it, you'll get a much better feel for all of the tools available to you. So there's some websites that are really great for this. Here's one that I'll point you to, shadertoy.com. It has a lot of community contributed shaders that you can play around with. You can edit them in real time. It uses a slightly different language, GLSL, the OpenGL shading language, but it's very similar. And some of these work with no texture at all. They're very cool. So explore this stuff, have some fun with it. See you later.